Throughout the course of this project, I have observed many different theories on quantum physics. Right now I'm going to be talking about two. There is Copenhagen's theory and Pilot's theory. Pilot's theory has way less consideration in the scientific world today than Copenhagen's theory, but it is way more grounded in reality. You see, Copenhagen's theory suggests that our mere observation can affect reality, while Pilot's theory says that everything has a determined outcome and our observations merely shift how the outcome will be. For instance, the double slit experiment, the thing that this whole project is over. When you shoot an electron, it goes through a slit and comes out on the other side, acting like it was a wave instead of a particle. But when you observe the wave or particle, you only see the particle, and it comes out the other side as if it was only a particle. Yet unobserved, it becomes a wave. Why does this happen? Well, let's look at Copenhagen's theory. Copenhagen's theory suggests that this is because our observation affects reality. It suggests that when you shoot out the electron, it becomes a wave of possibilities. Will it go this way? Will it go that way? This wave will tell us whether it will or not. And once that possibility of waves hits the two slits, the possibilities interfere with each other, making some more likely, making some less likely. And once that wave hits the monitor on the other side, it shows which one is most likely. That's why we see a wave pattern. And it would suggest, Copenhagen's theory would suggest that this entire time, the electron is both a particle and a wave at the same time. But if we set up a device to observe this electron, then we see the electron go through one of the slits and comes out the other side as not a wave. It never acted like a wave. It was an electron the entire time. So this electron was in a superposition of both wave and non-wave until we observed it, then it decided to just be a particle. Pilot's theory suggests that when you shoot out an electron, it's an electron and will always be an electron. And the act of observing it does not change it into a wave or change it into a particle. It will always be a particle. And that these two are separate from each other. You see, what it suggests is that there is this wave that everything, all subatomic particles, interact with. And when you shoot out this electron, it's riding the wave through the slit, and the pilot wave interferes with itself and every other particle in the universe, which determines which way the particle will go. And when we observe it, the observation of the particle affects where the pilot wave tells it to go. Now, this suggests that all particles in the universe affect themselves, despite locality. You see, something a million light years away, if it shifts even a little bit, can affect the pilot wave all the way over here. People don't think that this is possible, but we have seen through many experiments on particle entanglement that it is possible. And I would get more into particle entanglement if I had more time. You see, both of these theories have their own little quirks to them and reasons why you might not want to trust them entirely. Copenhagen's theory sort of breaks reality, while Pilot's theory breaks locality. Which one's right? Which one's wrong? We don't know. We haven't been able to prove either. But I have a theory that if we research more and more into Pilot's theory, then we will see that if we stay grounded in reality, the outcome will be more of not some mystical force, just things we don't know yet. So this is why I think that Pilot's theory is the correct and right theory on why particles act the way they do, and that Copenhagen's theory breaks reality too much, and it relies too much on mystical things happening that doesn't quite seem right in our observed reality. So this has been my physics project over quantum theory.